Have you ever wondered what actually happens after a tester finds a bug? Does the developer fix it immediately? Can a bug be rejected, reopened, or even postponed to a future release? If you are preparing for software testing interviews, studying software quality assurance, or starting your QA career, understanding the defect life cycle is absolutely essential. Hello everyone, welcome back to the Code Professor. In today's lesson, we are going to learn one of the most important topics in software testing, the defect life cycle, also known as the bug life cycle. We'll understand what the defect life cycle is, why it's important, and we'll go through every stage step by step using easy to understand real world example. By the end of this video, you'll clearly understand how a defect moves from being reported by a tester until it is finally closed, and you'll be able to answer interview questions on this topic with confidence. So, if you are ready to master the defect life cycle, let's get started. When we talk about software testing, one important term that we often hear is defect. So, what exactly is a defect? A defect is any error, fault, or problem in the software that causes the application to behave differently from what was expected. In simple terms, if the actual result does not match the expected result, we can identify it as a defect. Let's understand this with an example. Imagine that a login page should allow users to sign in successfully when they enter the correct username and password. This is the expected behavior. However, if the system displays an error message even when the correct credentials are entered, the actual behavior is different from the expected behavior. Therefore, this issue is considered a defect. A defect can also be viewed as an obstacle that prevents testers or end users from using the application smoothly. Instead of functioning correctly, the software may crash, display incorrect information, or fail to perform a required action. As a result, the user experience is negatively affected. Therefore, we can conclude that a defect is a deviation between the expected behavior of the software and its actual behavior. Whenever the software does not perform as intended, that issue is identified and reported as a defect. Before we learn about the defect life cycle, it's important to understand three related terms that students often confuse: error, defect, and failure. Although they sound similar, they represent three different stages of a problem in software development. Let's understand them one by one. The first one is an error. An error is a human mistake made by a developer, designer, tester, or any member of the development team. This mistake usually happens because of misunderstanding the requirements, lack of knowledge, incorrect calculations, or simple typing mistakes. For example, imagine a developer is writing the logic to calculate a student's average marks. Instead of dividing the total marks by the number of subjects, the developer accidentally divides by the wrong number. This human mistake is called an error. Remember, an error is made by a person, not by the software. Now, what happens because of that error? The human mistake gets introduced into the software as a defect. A defect is a fault or bug in the source code or software that causes the application to behave incorrectly. Continuing with our previous example, because the developer wrote the wrong calculation logic, the software now contains incorrect code. This incorrect implementation is known as a defect. So, you can think of it this way. The developer's error becomes a defect in the software. We can represent it like this, right? Finally, when the user or tester runs the application, the defect may cause the software to produce an incorrect result. This is called a failure. A failure occurs when the software does not perform its intended function or produces an unexpected output. For example, if the student should receive an average of 85, but the system displays 72 because of the incorrect calculation logic, the software has failed. This incorrect behavior that the user experiences is known as a failure. What is severity? Severity refers to the technical impact of a defect on the software system. In other words, it tells us how seriously the defect affects the functionality of the application. Usually, severity is determined by the tester or the QA team because they evaluate how much the defect impacts the system from a technical perspective. For example, if the application crashes every time a user clicks the submit button, that defect has a high severity because a major function of the system is not working. So remember this. Severity answers the question, how badly is the system affected? What is priority? Now, let's talk about priority. Priority refers to the business urgency of fixing a defect. It tells the development team how quickly the defect should be fixed. Priority is usually decided by the project manager, product owner, or business team because they understand the business impact and customer expectations. A defect may not have a big technical impact, but if it affects customers or the company's reputation, it may still need to be fixed immediately. So remember this, priority answers the question like, how soon should this defect be fixed? Let's look at some examples. Example 1. Login failure. Imagine users cannot log into an online banking system. Since users cannot access the application at all, this defect has a high technical impact. At the same time, because customers cannot use the system, the business also wants if fixed immediately. It fixed immediately. Therefore, severity is high, priority is high, right? This is an example of a high severity and high priority. Example 2. Typo on home page. Now imagine the home page displays the message like this instead of this, right? Technically, the application works perfectly. Users can still log in, place orders, and use every feature. So, the severity is low because the functionality is not affected. However, this typo appears on the home page, which is seen by every customer. It creates a poor first impression and affects the company's professional image. Therefore, the business may ask developers to fix it immediately. So, the defect has severity is low, priority is high. What is defect triage? The word triage means sorting or prioritizing. In software testing, the defect triage process is a meeting where the project team reviews all newly reported defects and decides how each defect should be handled. The main goal of this meeting is to ensure that the team spends its time and resources on fixing the most important defects first. When is a defect triage meeting held? A defect triage meeting is usually held daily or weekly, depending on the project's requirements. For example, in a fast-paced agile project with frequent releases, the team may conduct defect triage every day. Second one, in larger projects or projects with longer release cycles, the meeting may be held once a week. So, the meeting schedule depends on the project's size, complexity, and development methodology. Who participates in the defect triage meeting? Several key stakeholders participate in this meeting. QA lead. QA lead represents the testing team. The QA lead explains the reported defects, provides evidence such as screenshots or test results, and describes the severity and impact of each defect. The next one, development lead. The developers lead analysis the technical aspects of the defect. They estimate how difficult it will be to fix, identify possible solutions, and discuss the development effort required. Sorry, it's my bad. The first sentence should be like this, right? The development lead analysis the technical aspects of the defect, right? Sorry. The next one, product owner. The product owner represents the business perspective. They decide how important the defect is to customers and whether it should be fixed immediately or can wait until a future release. What decisions are made during defect triage? At the end of the discussion, the team makes decisions about each defect. First one, fix now. If the defect is critical and affects important business functions, the team decides to fix it immediately. For examples, users cannot log in, complete payments, or submit orders. The next one, fix later. If the defect has a low business impact or can safely wait, it is scheduled for future release. For example, a minor UI alignment issue or a cosmetic problem. Sometimes a reported issue is not actually a defect. It may be the correct behavior according to the requirements. Or the tester may have misunderstood the expected functionality. In such cases, the defect is marked as rejected. The next one is duplicate. Occasionally, two testers report the same defect independently. Instead of creating multiple records for the same issue, one report is kept while the others are marked as duplicate. This helps keep the defect tracking system organized. The last one is assign owner. Finally, every accepted defect is assigned to a responsible developer or development team. This ensures there is clear ownership and everyone knows who is responsible for fixing the issue. The next topic is root cause analysis. Also, we can say RCA. Finding a defect is only part of a tester's job. A good software team also wants to understand why the defect happened in the first place. If we only fix the defect without identifying its actual cause, the same type of problem may happen again in the future. This is where root cause analysis becomes important. What is root cause analysis or RCA? Root cause analysis is a systematic process used to identify the real underlying causes of a defect instead of just fixing its symptoms. In simple terms, RCA answers the question like, why did this defect occur? Once we know the real cause, the team can take preventive actions so that similar defects do not occur again. There are several techniques used to perform root cause analysis. Today, we'll discuss two of the most popular methods. First one, the 5 whys technique. The 5 whys is one of the simplest and most effective RCA techniques. The idea is very straightforward. Whenever a problem occurs, we repeated ask why until we discover the actual root cause. Although it is called the 5 whys. You don't always have to ask exactly 5 times. Sometimes 3 questions are enough, while other situations may require more than 5. The goal is simply to continue asking why until you reach the real reason behind the problem. Let's see an example of the 5 whys. Let's consider real-world software testing example. Suppose users report the following bug. The bug is payment failed. Now we begin asking why. Why did the payment fail? Because the payment API returned an error. Why did the API return an error? Because the request timed out. Why did the request time out? Because the server configuration was incorrect. After investigating further, the team may discover that the server timeout value was configured to low during deployment. Now we have identified the root cause, not just the symptom. Notice that the payment failure was only the visible problem. The actual issue was the incorrect server configuration. Another popular root cause analysis technique is the fishbone diagram, also known as the cause and effect diagram or the Ishikawa diagram. It is called a fishbone diagram because its structure looks like the skeleton of a fish. The head of the fish represents the problem, while each bone represents a possible category of causes. Instead of asking only why, the fishbone diagram encourages teams to think about multiple possible causes from different perspectives. Some common categories include people. Was the defect caused by human? Caused by human error or lack of training. Process. Was there a problem in the development or testing process? Technology. Was the issue caused by software, hardware, or development tools? Right? Environment. Was the testing of production environment configured incorrectly? Requirements. Were the requirements unclear, incomplete, or misunderstood? By examining all these categories, the team can systematically identify the true root cause of the defect. What are defect metrics? Defect metrics are measurements used to evaluate the quality of software and the effectiveness of the testing process. In simple terms, defect metrics help us answer questions such as how many defects were found, is the software improving, how effective is our testing, how quickly are defects being fixed. By analyzing these metrics, project managers and QA teams can make better decisions and continuously improve software quality. Let's look at some of the most commonly used defect metrics. The first metric is defect density. Defect density measures how many defects exist relative to the size of the software. It helps us understand the quality of the software code. The formula is this. The size of the software can be measured in different ways, such as lines of code or function points. Let's discuss an example. Suppose a software application contains 10,000 lines of code and testers discover 50 defects. The defect density would be how many number of defects? 50. And we have 10,000 lines of code, right? It is equal to size of the software, right? Then you can get the answer. Solve it yourself, right? 0.005 defects per line of code. A lower defect density generally indicates better software quality, while a higher defect density suggests that the software contains more defects relative to its size. The next metric is defect leakage. Defect leakage measures the number of defects that were not found during testing but were discovered after the software was released to customers. In other words, these are defects that escaped the testing process. For an example, imagine the QA team found 95 defects before release. After the software was deployed, customers reported 5 additional defects. Those 5 defects represent defect leakage. A low defect leakage is always desirable because it means the testing process successfully detected most of the defects before release. Sometimes testers report issues that are later reviewed by the development team. However, not every reported issue is an actual defect. Some reports may be not reproducible, duplicate defects, intended system behavior, invalid reports. The defect rejection rate measures the percentage of reported defects that are rejected. For an example, suppose testers reported 100 defects. After reviewing them, developers rejected 10 defects because they were either duplicates or not actual defects. So, the defect rejected rate is 10%. A very high rejection rate may indicate that defect reports are under or that testers need a better understanding of the system requirements. The final metric is mean time to fix, often abbreviated as MTTF. Mean time to fix measures the average amount of time required to resolve a defect after it has been reported. This metric helps teams understand how efficiently defects are being fixed. For an example, suppose 3 defects look 2 days to fix, 4 days to fix, and 3 days to fix. The average time is 3. You should divide the total days by 3, right? Like this, right? So the mean time to fix is 3 days. A lower mean time to fix generally indicates a more efficient development team because defects are resolved more quickly. Right? These are the compulsory attributes of software defects. What is defect status? Defect status, also known as bug status. It refers to the current state of a defect in its life cycle. In simple terms, it tells us where the defect is at this moment. Think of it like tracking the delivery of an online order. When you place an order, it goes through different stages such as order placed, packed, shipped, and delivered. Similarly, a software defect also moves through different stages, and each stage is represented by a defect status. The purpose of assigning a defect status is to help everyone in the project understand the current progress of the defect. By looking at the status, the team can immediately answer questions like: has the defect been reported? Is it currently being fixed? Has the fix been completed? Has the tester verified the fix? Or has the defect already been closed? Without defect statuses, it would be very difficult to track hundreds or even thousands of defects in a software project. Why is defect status important? Defect status plays a vital role in defect management because it helps the entire project team monitor the progress of each reported issue. It provides clear communication between testers, developers, project managers, and other stakeholders. Instead of asking each developer for updates, anyone can simply check the defect tracking system and see the current status of a defect. This improves transparency, reduces confusion, and ensures that no reported defect is forgotten. For an example, let's understand this with a simple example. Suppose you are testing an online shopping application. While testing the payment page, you discover that customers cannot complete their payment using a credit card. You report this issue in the defect tracking tool. At first, the defect status might be new, indicating that the defect has just been reported. Later, the developer starts working on it, so the status changes to assigned or in progress. After fixing the issue, the developer changes the status to fixed. The tester then retests the application. If the payment now works correctly, the tester changes the status to closed. However, if the problem still exists, the tester changes the status to reopened and the defect goes back to the developer for further investigation. This sequence of status changes allows the entire team to know exactly where the defect is in its life cycle. What's the defect life cycle? The defect life cycle, also known as the bug life cycle, is the series of stages or states that a defect goes through from the moment it is discovered until it is finally closed. In simple terms, it describes the journey of a defect. Think of it as the life journey of a bug. Just as a student progresses through different stages from admission to graduation, a defect also passes through several stages before it is completely resolved. Every reported defect follows a structured process to ensure that it is properly tracked, assigned, fixed, tested, and finally closed. Why do we need the defect life cycle? You might wonder, why can't a developer simply fix the bug as soon as it's reported? The answer is that software projects often contain hundreds or even thousands of defects. Sorry, it's not after, it should be. Projects often contain hundreds or even thousands of defects, right? Without a proper process, defects could easily be forgotten, assigned to the wrong developer, fixed incorrectly, or even released to customers. The defect life cycle provides a systematic way to manage every reported defect. It ensures that everyone involved in the project knows who is currently responsible for the defect, what stage the defect is in, whether it has been fixed, whether it has been verified by the testing team, whether it is ready to be closed. This makes the defect management process organized, efficient, and easy to monitor. Let's see a real world example. Let's understand this with a practical example. Imagine you are testing an online shopping application. While placing an order, you notice that clicking the Pay Now button does nothing. As a tester, you report this issue in the defect tracking system. From that moment, the defect begins its life cycle. The defect is assigned to a developer. The developer investigates the issue, identifies the cause, and fixes the code. Once the fix is complete, the defect is returned to the tester. The tester then retests the payment functionality. If everything works correctly, the defect is closed. If the issue still exists, the tester reopens the defect and the life cycle continues until the problem is complete. Sorry, the word should be continues. Sorry, my bad. It's not continuous, right? It should be corrected like this, right? If the issue still exists, the tester reopens the defect and the life cycle continues until the problem is completely resolved. This entire journey from discovering the defect to closing it is called the defect life cycle. Why is the defect life cycle important? The defect life cycle provides many benefits to a software development team. It helps Track every defect from beginning to end. Improve communication between testers and developers. Assign clear ownership for every defect. Prevent defects from being forgotten or overlooked. And ensure that defects are properly verified before the software is released. Make the defect fixing process systematic, organized, and efficient. Without a defect life cycle, managing defects in large software projects would become confusing and difficult. You should make a checklist and ensure whether you have passed all the points before reporting a bug like this, right? You should consolidate all the points on how to write a good bug report like this, right? Whenever a tester finds a defect, it is not enough to simply tell the developer there is a bug, right? Instead, the tester must prepare a bug report that contains all the necessary information required for the development. Developers to understand, reproduce, and fix the defect. A well-written bug report reduces confusion, improves communication, and helps developers resolve defects more quickly. The first field is the defect ID. This is the unique identification number assigned to every defect. It helps the team track and reference the defect throughout its life cycle. For example, we can write defect IDs like this, right? In most defect management tools such as Jira or Bugzilla, this ID is generated automatically. This field records who reported the defect. Although defects are usually reported by QA testers, they can also be reported by developers, business analysts, subject matter experts, customers. Knowing who reported the defect makes it easier to contact the person if additional information is needed, right? Third one, defect reported date. This field records the date on which the defect was reported. It helps the project team monitor how long the defect has remained unresolved and supports project tracking and reporting. The next section, who detected. This field identifies the role or designation of the person who discovered the defect. For example, QA tester, developer, business analyst, SME, customer. This information helps the team understand during which phase the defect was discovered. The next section is how detected. This field explains how the defect was found. Common methods include testing, code review, walkthrough, peer review. Knowing how the defect was detected helps improve the overall software development process. The next section, project name. This field specifies the name of the project or product where the defect occurred. For example, student management system, online banking system, e-commerce website. This is especially useful when a company manages multiple projects. The next one, release or build version. The tester should mention the software version or build number where the defect was found. For example, version 2.1, build 105. This helps developers identify the exact version affected by the defect. The next one, defect or enhancement. Here we specify whether the reported issue is a defect, meaning something is not working correctly, an enhancement, meaning a new feature or improvement is being requested. This helps the development team classify the issue correctly. The next one, environment. The environment describes where the defect occurred. This usually includes operating system, browser, device, database, application, version. For example, Windows 11, Google Chrome version 138, Android 15, Mac OS, Firefox. Providing environment details helps developers reproduce the issue under the same conditions. The next one, priority. The priority indicates how urgently the defect should be fixed. Common values are high, medium, and low. Remember, priority is based on business urgency. Next one, severity. The severity indicates how seriously the defect affects the system. Typical values include critical, high, medium, and low. Remember, severity measures technical impact. The next one, status. The status shows the current stage of the defect in the defect life cycle. Some common statuses include new, assigned, open, fixed, ready for testing, verified, closed, reopened, duplicate, deferred, rejected, cannot be fixed, not reproducible, need more information. As the defect moves through the life cycle, its status changes accordingly. The next one, description. This is one of the most important section of the bug report. The description should clearly explain what the problem is, where it occurred, when it occurred. The more detailed and accurate the description, the easier it is for developers to understand the issue. The next one, steps to reproduce. This section provides the exact steps required to reproduce the defect. The steps should be written so clearly that anyone who has never used the application can reproduce the same problem. For example, open the application, log in using valid credentials, add an item to the cart, click the Pay Now button. Following these steps should consistently reproduce the defect. The next one, URL. If the application is web-based, include the URL where the defect occurred. For example, https //demo.onlineshop.com/payment. This helps developers navigate directly to the affected page, right? The next one, expected result. The expected result describes what should have happened. according to the system requirements or test case. For example, the payment should be processed successfully and the order confirmation page should be displayed. The next one, actual result. The actual result describes what actually happened during testing. For example, after clicking the Pay Now button, the application displayed a 500 internal server error. This comparison between the expected and actual results clearly explains the defect. The next one, defect close date. Finally, the defect close date records the date when the defect was officially closed. This date is entered only after the tester verifies that the defect has been fixed successfully and is no longer reproducible, right? If you get something from this video, don't forget to subscribe us, like, comment and share with your friends. Bye bye.